Okay, so it says determine the couple moment acting on the beam here for F22, 422, and so we can look and we can say, oh, we've got 2 kilonewton forces acting. Okay, great, no problem. All right, so let's kind of like extend their line of action. This guy comes down here. This guy comes up this way. And so if we can get this distance right here across here, then we would know that our moment is simply going to be 10,000 times whatever that thing is right there. Okay. Now, all right. So here's the deal. I mean, that wouldn't be a terrible problem to do, but we can do something that's just a little bit easier. So let me get rid of all that stuff and let me show you a little easier approach. Okay. So let's take the 10 kilonewton forces and split them into their components. Now, if we do that, then what we've got is we've got a 6 this way and a 6 this way. Okay. And the line of action on those comes across, and then we know the distance here is 2. Okay. And so that tells us then that we can get a moment from that. And that's going to be, that moment is going to be 6 times the distance between those, which is 2. All right. And that's going to be positive, just like that. All right. Now we could also then do the vertical components, which I've got an 8 here. And I've got an 8 here. And if we look at their lines of action like this, then we know the distance between those is 4. All right. And those are going to create a negative moment. All right. So that, I mean, clockwise. So that's going to be negative. So we could say that that's minus 8 times the distance between them, which is 4. So we're looking at 12 minus 32 or negative 20 or 20 clockwise. Okay. Sort of like that. Okay. So if you've got something that's in there at an angle, you don't have to work it at an angle and find that perpendicular distance. Split it up into a pair of perpendicular forces and work it that way. Okay.